Another type of compounding that can exist is called continuous compounding. In continuous compounding, the compounding interval n is infinitely small. Basically, it's not even going to be every minute you're getting interest, or even every second you're getting interest. It's going to be every fraction of a second the account is generating interest. So under continuous compounding, this is going to be dictated by this formula. A is equal to PE raised to the RT power. Now in this formula, A is still going to be that future value of the account. P is going to be the principal or present value or starting value of the account. Little r is the annual interest rate expressed in decimal form, and T is the time in years. This E right here is not a variable. This E is an irrational number. It's approximately equal to 2.7. It's sometimes called Euler's number. Okay, so it's kind of like pi. So, pi has a decimal approximation of 3.14. This is another irrational number, E, which is approximately equal to about 2.7. All scientific calculators have E stored in their calculator's memory. So let's see an example of using this continuous compounding formula. So suppose you found a bank that offers an APR of 6.75% compounded continuously. What is the future value of your investment if you invest $875 for 7 years? Now you would think maybe because you're getting interest every fraction of a second that this count would blow up and it would become super huge really fast. That's actually not going to happen. So let's see if we were to make this investment for 7 years. Let's find out how much money this $875 grows to. So because this one is being compounded continuously, continuous compounding is dictated by this formula. So now I'm going to use A is equal to PE raised to the RT power. So it looks kind of like PERT over here. The future value of the account is unknown. I'm going to start with an investment of $875, and then I'm going to have E, and then the exponent for that is going to be 0.0675, and then that's its interest rate and its decimal form, and then my time is going to be 7 years. Okay, so this is what we want to key into our calculator. Now again, if you want, you could go ahead and you could evaluate that exponent just to figure out what that number is up there. And then you could just key in that number. So if you wanted to do that, you would have 875E, and then this exponent evaluates to 0.4725. Otherwise, if you wanted to key it into this form, I'll talk about how to do that on your calculator. Alright, so going to my graphing calculator, I have my 875. Now in this calculator, I've got two different options for E. Now right above my division symbol right here is the exponential base E, the Euler's number. It's a very common thing though when we use this number that we want to raise it to an exponent. In most applications, that's where this number actually occurs. So you might notice over here they actually have one already built in that has Euler's number E and already has a variable up here for the exponent, so it's already going to build that structure. So I'm going to use this version instead, just so that way it's one less button press on my calculator. If I had to do this one, then I would just have to hit the exponent key to start my exponent. So I'm going to hit second and then this button to grab that function. And then notice in my calculator it's already grabbed Euler's number, I've already started my exponent thing, and it's already given me parentheses to ask me what do I want up there in the exponent. So at this point in time you could key in that simplified exponent that we had, or because it's already introducing the parentheses for me right here, I can just go ahead and key in what I want up there and it'll do the operation for me. So it was 0.0675 times 7. So then I'm just going to hit enter to evaluate that. Alright, so then rounding this to 2 decimal places, because this is 5 or bigger, that's going to push that number up, which is going to push that number up. So ultimately then we get that this future value is going to be $1,403 and then 50 cents. So this is the formula that you would want to use if you ever see that the compounding is happening continuously. You can't use that general compounding formula because there's going to be no value that you could use for n. It's basically going to be like positive infinity. It's a number that's so big that we, instead of using that formula, we use this formula instead.